This video is going to talk about the coordinate plane. And there's a couple things you need to remember about the coordinate plane. The first is how the coordinates work. So remember that it goes x, y, and x is the direction on the x-axis, y is the direction on the y-axis, which translates to run, jump. Run will tell you which direction to run and how many. Jump will tell you which direction to jump and how many. X is run, Y is jump. So, for that, because X is run, and you run along the horizontal axis, that makes this the x-axis. And Y is jump, so Y is the up and down or the vertical axis, which you can also remember by writing the Y so that it has that vertical part in it, right there, that just goes up and down. What you also need to remember is that this right here, where the x-axis and the y-axis meet, that's called the origin, and that's always 0, 0. So, there's another thing that you need to know about coordinate grids. Coordinate grids are split up into, or coordinate planes, coordinate grids, they are split up into 4 quadrants. And what a quadrant is, as you can probably guess from the word quad, is fourths. So there are 4 quadrants. And just like there are numbers on a clock, you can remember where the 1 and 4, where the largest and the smallest quadrants are by looking at a clock. So if we pretend like this clock is a coordinate grid, and you look at where the largest and the smallest numbers of quadrants are, you look at where the 1 is, and you look at where the 4 is. 1 is going to be in this quadrant. So this is quadrant 1. Quadrant 4 is going to be down here because that's where the 4 is. Quadrants are written in Roman numerals. It's not really that hard. We just got the 1, 2, 3, and the 4. Now, coordinate grids go in a counterclockwise direction. So after 1, next to it will be 2. And then we have first and second place on top, third and fourth go down below. 3 goes right here. So those are the quadrants. And the quadrants are going to tell you the positive or negative sign of any numbers that are in them. Because if I take a number, and if I run in a positive direction, which would be going this way, it's going to be either in quadrant 1 or quadrant 4. So my run number on this side is always going to be positive. If I run and then I jump up, I'm going to land in quadrant 1. So quadrant 1 has a positive coordinate pair. Quadrant 4, you're running in a positive direction, but then you're falling. So that has a negative coordinate pair. Over here, you're always running negative. So to land in the second quadrant, you would want to run in a negative direction and then jump in a positive direction. Anything that says negative, positive is going to land you up in quadrant 2. Quadrant 3 is going to be completely negative. You're going to run in a negative direction, you're going to run backwards, and then you're going to fall. And there you get to negative, negative. So, if we look over here, and we try to put these numbers, and we try to assign them to quadrants, we're going to see that 2, 4 has us running in a positive direction and falling. Doesn't matter where we're going right now, but I can tell by the positive, negative, that I'm going to end up in quadrant 4. When I look at negative 6, 5, that means I'm going to run negative and jump positive. That's going to land me in quadrant 2. 8, 14, those are both positive numbers, so I'm going to run positive and then jump positive. That will land me quadrant 1. -2, -7 will have me running backwards and then falling, which will land me in quadrant 3. And that's what you need to know about how the quadrants work out. The next thing that you need to know about is reflections. And reflections are going to be like looking in a mirror. Give you a second to look at everything that's up here. Great. So what I'm going to do is I'm going to erase all of this, including part of the problem. So, if I have 0.45, that's going to have me running 1, 2, 3, 4, jumping 1, 2, 3, 4, 5. So there's my point. Great. And the problem is asking me to reflect that point across the x-axis, which means the x-axis is going to be a mirror for it. So I'm going to imagine that this right here is a mirror. And if right now this point is 1, 2, 3, 4, 5 spots away from the mirror, that means when it's reflected, it's also going to be 1, 2, 3, 4, 5 spots away from the mirror. So when I figure out where that point is now, it's still 4 down the x. It still ran 4, but now instead of jumping 5, it fell 5. So instead of having 5 here, it's going to be -5. Which means when I reflect something across the x-axis, that means the x number stays the same. My x, my 4, stays the same. And I found the opposite of my y number. 5 became -5. I found the opposite of that. Let's go ahead and let's look at reflecting 2, 7 across the y-axis. So first I want to find 2, 7. And I know I'm going to run 2 and then jump 1, 2, 3, 4, 5, 6, 7. And now, because I'm going to reflect it across the y-axis, this is no longer my mirror. That's the x-axis. My mirror is now going to be the y-axis. So now, because it's 2 spots away from the mirror, I'm going to reflect it 2 spots away from the mirror, which means my new point is still going to be 7 in the air. So that jump is still going to be 7. The y stays the same. It's the x that's now different. Instead of being 2, now it's -2. So when you reflect something across the axis, you keep the axis it's asking about, and then you have to find the opposite of the other axis. What you're going to do is you are going to tell me what quadrant -3, 18 is in. You're then going to tell me what the new coordinates would be of -2, -6, reflected across the x-axis.